today to begin with, we're doing combining like terms to solve equations. How many know what it means to combine like terms? How many know what like terms are? All right, tell your neighbor what a like term is. Okay, what are like terms? Volunteer. What do we got? What are like terms? Oh, come on, man. Brennan.
Well, maybe it's like when like a number has a variable, or if it doesn't, those can be like terms, but it isn't like terms if it's like a number with a variable and like just regular number.
Okay, so like a number with a variable and a regular number, say like this, these aren't like terms.
No, but like
Okay.
2x or 5 plus 5.
Okay, so if you had like 5 plus 5, 5 plus 5, those are like terms. You can put those together. Everyone agree with that? Yeah, 5 plus 5 is 10. We know this. Okay. What could you put together with a 2x if you had, like, what's the like term for 2x? Someone else? Yes, Josh?
3x.
Yeah, 3x. Okay. Something else with an x attached. Okay, how many x's do I have there? Audrey? Yeah, you have 5 x's. 5 x's. Okay, so we have 2 x's and 3 x's. That gives us 5 x's. So what you're doing when you're combining like terms is you're really adding these numbers in front. Do we know what those numbers are called? Those numbers are called coefficients. Okay? So it's a math term. It's one that you want to know the vocabulary for. That's called a coefficient. So in this equation, what's the coefficient? Go ahead and tell your neighbor there. All right. Don't hear a lot of talking, dude. It's like crickets out there. Okay. What number is attached to your variable? Everyone on your fingers right now. All right. 2. All right. I got 1, 2. All right. Got a few. Chelsea, what do you got? 2. How many agree that it's a 2? That's the thing attached to that x. Okay. That is your coefficient. Okay, it's good to know the vocab. So if you didn't know that, it's something you want to add to your notes. Coefficient is the thing attached to your variable. If you have multiple variables, then you have multiple coefficients. So if this was my equation, 2x plus 3x equals 5x, that would mean that 2, 3, and 5 are all coefficients. I'd have 3 different coefficients. All right. We kind of talked about like terms. Like terms are when you have the same variable or the lack of a variable. What would happen though if I had, say, like 2x plus 3x squared? Can I put those things together? Anyone know that? How many say, yep, you can? Nope, you can't. Yeah, you can't. You're counting different things. This 2x means x plus x. How many of you remember counting when you were younger? Like your parents were teaching you to count. You'd be like 1, 2, and you get to 3, and they're like, "Woo, my kid's up." Then then you got to a point and you started multiplying. How many remember learning your math facts? Like 2 times 2, 3 times. Okay, so we taught you to begin with, or someone taught you, hey, you count, and then you could do skip counting. Maybe you counted by 2. You said 2 plus 2 plus 2 plus 2. How many did that before you got to multiplication? You remember like adding multiple 2's. Okay, and so then eventually whoever was teaching you go, hey, there's a quick way to do that. That's 1, 2, 3, 4, 5 of those. You have 5 of those too, so really it's 5 times 2, and you're like, whoa, it's amazing magic, and you're like, man, that's awesome. It's 10. It's like shorthand. Okay, well that's all you're doing here. So you apply it differently, right? The 2 times x means you have x plus x. The 3 times x squared means you have 3 of these things. X squared plus x squared plus x squared. So when you write it out like that, you have unlike pieces. You can't add them up. Okay? Now most of you look at this and just go, well, yeah, I know you can't because there's like a squared here and there's not one there. Okay, that's good. The reason is because you don't have like parts. Okay? They're not the same thing. You're not adding the same thing. Okay? It'd be like giving you pennies and quarters and saying, how many quarters do you have? And your buddy starts adding them for you, and they start counting pennies as quarters. They're like, what's wrong with you? Those are pennies, man. I want to know how many quarters. You're like, oh, dude, they're all just coins. It's good. You're like, no, these are, you gotta add the like things together. Okay, you need textbook. I need you to find example 1 on page 120 and answer questions 4A and B. Work with your groupies. Okay, here you go. Okay, so you're looking at page 120, trying to complete question 4A and B. So you complete it on your own, and then compare with a groupie, or if you're struggling, talk with your groupie. I'll be walking around to help out. Notice, for some people it's helpful when you're putting like terms together to circle the terms that go together. So you got 9A and minus A. And notice I put the minus sign with the A here. The sign that's directly in front of it, if you're reading from left to right, the sign that comes directly in front of it actually goes with that term. So this right here, it has 1, 2, 3, 4, 5 terms, this expression. These two are like terms. So 9A minus A is 8A. We have a 10, so I'm going to use a different shape here. And what goes with the 10 is the minus 5, so 10 minus 5 is positive 5. And then I just have the 3x kind of hanging by itself, so plus 3x. Now, Brendan did a good job at writing that out there. A lot of times we put all of our variables first, usually we do that, in alphabetical order. Okay, so A, X, and then the constants at the end. And if there is a power, we put the power ahead, the biggest power first. Okay, so well done. Good job, Brendan. Thank you. How many got that? Good. And we got Cole here. Cole putting together the negative 9m and the negative m. Negative 9m minus m is negative 10m. I think that's what you meant right here, right, Cole? Okay, forgot the m. That's all right. We've got our negative 4 and nothing else. So just minus 4. Good. And then we have our positive y and plus 2y. That gives us a total of 3y's. So once again, if we put those in order, we go negative 10m plus 3y minus 4. It's kind of like these things are puzzle pieces you can move around. All right? Very good. Hey, thank you for volunteering. Any questions on those? Okay, does anyone know the difference between an expression and an equation? Patrick, what's the difference there?
The difference between an expression and an equation is an expression, you can only simplify it until you only have just a couple numbers left, but with an equation you can solve or find the answer.
Okay, a lot of times you can find the answer with an equation. Trinity?
I was going to say, an expression doesn't have an equal sign and an equation does.
Good. An expression doesn't have an equal sign, and an equation does. So if I said solve these equations, notice I can solve them because first there's a single variable and it's a single equation. Second, it has an equal sign. An equation is made up of two expressions. This is an expression and this is an expression. Okay, things on both sides of the equal sign. So what you had up here, this is an expression because there's no equal sign. If we said equals 20, then you would have an equation. And in that case, we couldn't solve it unless we had one other equation because they're two variables. But when there's only one variable, we only need one equation to solve. Okay? So let's go ahead and solve this by combining like terms here. There you go. And then give that one a shot. And then go ahead and give that one. Draw your lines, copy them down. Here we go. I'm going to call people individually. All right? You bring your buddy up. So Jennifer, you get letter A, and then I'll call someone up for B here in a minute. And remember, if you get called up, you can bring anyone you want up with you. They can't repeat. Anyone want to volunteer for B? All right. Mackenzie's got C. That'll be good. Hey, checking letter A out. Notice Jennifer put the B and the 5B together to get 6B. And then that equals 42. Divided both sides by 6. So 1B is equal to 7. Good. Easy try letter C there. notice on letter C, Mackenzie put together the 4m minus 2m. These two pieces right here together makes 2m plus 1. Subtract 1 on both sides, you get 2m equals 6. Divide by 2, you get 1m equals 3. Good job, Mackenzie. All right, volunteer for B? No volunteer for B. All right, hold on. I'm going to go ahead and draw a number. We get person number 24. Lucky number 24 is Chelsea. Yes, Chelsea. You guys are going to make me draw numbers all year, right?
Scares me.
Huh?
I think I'm gonna get calls.
Thank you, Chelsea. Woo. All right. Now Chelsea putting together the 3x minus 4x to give us negative x plus 6. Okay, and we've got we want to move everything away from the x. So rather than moving the 2 here, I think what we're going to do, let me take this line right here and bring it down here. Okay, so we actually want to say negative x plus 6 equaling negative 2. Rather than moving the 2 and adding it to both sides, let's bring the 6 away from, I want to bring the things away from the variable. So we'll subtract 6 on both sides. You give us negative x equals negative 8. If negative x equals negative 8, then that means positive x equals positive 8. Okay? So probably up here, from here on, we don't want to do that. Okay? So move everything away from the side of the variable. Good. Thank you for giving me an opportunity to teach there. So I appreciate that. Okay. Any questions? Everyone rate yourself.